Hey, have you ever really stopped to think about what's going on inside your phone or your laptop? What's the brain that makes it all work? Well, today, we're going to deconstruct one of the most incredible pieces of technology ever created, the Central Processing Unit. You probably know it as the CPU. So, let's get right into it.
So take a look at this. This tiny little thing, it is, no exaggeration, the engine of our modern world. Seriously, every single time you tap your screen, click a mouse, or even just watch a video, this is where all that magic is happening. So over the next few minutes, we're going to tear this thing apart, figuratively of course, and see exactly what it is, how it works, and why it's so incredibly important.
All right, so here's the plan for our little journey. First, we'll cover what a CPU actually is. Then we'll get into how we measure its speed. After that, we're going inside to see what it's made of. We'll look at its core thinking process, a little bit of its history, and then we'll wrap up with a quick word on GPUs.
Okay, first up, the computer's brain. So, what is a CPU? I mean, we throw that term brain around all the time, but what are we actually talking about here?
Well, we're talking about the CPU. And yeah, that stands for Central Processing Unit. It's the main chip in a computer where pretty much all the real work, all the heavy lifting gets done. You'll also just hear it called the processor, which, makes a ton of sense because that's exactly what it does. It processes things.
And honestly, that brain analogy, it's pretty spot on. Think about it. When you tell your computer to do something, anything at all, the CPU is the part that gets that instruction, figures out what it means, and then actually carries it out. It's the command center for every single data processing operation, turning a bunch of ones and zeros into, something you can actually use.
All right, so if it's a brain, a logical question is, how fast can it think? How do we even measure the speed of a processor?
So the main way we measure this is in hertz, or more commonly, gigahertz. That's the GHz you always see on a spec sheet. This is what we call its clock speed. You can think of it like a heartbeat. It's the number of cycles or operations the CPU can run through every single second. Now, there are other ways to measure it, like MIPS, which is millions of instructions per second. But really, that clock speed, that gigahertz number, is the one you'll see most. And yeah, for the most part, a bigger number means a faster brain. Okay, we know it's a brain and we know how to measure its speed, but what's actually going on inside that little chip? Let's zoom way in and take a look at the three key parts that make the whole thing work.
So here's a basic diagram of what the inside of a CPU looks like. At its core, pun intended, it's really about three main parts that work together like a well-oiled machine. You've got the control unit, the arithmetic logic unit, and the memory unit or registers. Let's break down what each of these does.
First up, you've got the control unit, or CU. I love the analogy of an orchestra conductor for this one. It doesn't play any instruments itself, but it tells everyone else what to do and when to do it. It fetches instructions from memory, figures out what they mean, and then directs the traffic, telling all the other parts of the CPU how to respond. It's the manager, the boss of the whole operation. Next, we have the arithmetic logic unit, the ALU. Now, this is the part that does the math. It's the calculator of the CPU. When the control unit barks an order, the ALU is the one that gets to work. It handles all the basics, adding, subtracting, but it also does all the logic operations, stuff like comparing two numbers to see which is bigger. This is where the actual thinking, the number crunching, really happens. And the third piece of the puzzle is the memory unit, which is basically a set of what we call registers. The best way to think of this is as the CPU's own personal super-fast scratch pad. It's a tiny bit of memory located right on the chip. This is where it holds the data that the ALU needs to work with at that exact moment. And because it's so close to the action, it is, by far, the fastest memory in your entire computer.
Okay, so we've got our director, our calculator, and our scratch pad. So how do they all work together? Well, it all comes down to a simple but incredibly fast three-step process that repeats over and over again. It's called the fetch, decode, execute cycle. And you can think of this as the literal heartbeat of the CPU. Step 1, it fetches an instruction from the computer's main memory. Step 2, the control unit decodes that instruction to figure out what needs to be done. And step 3, the ALU executes the command. That's it. Fetch, decode, execute. It's a simple loop, but it happens billions of times every second. That's where the power comes from.
So that basic cycle, fetch, decode, execute, has been the foundation of computing for decades. But the CPUs themselves? Oh, they have changed in some pretty mind-blowing ways. So let's zoom back out a bit and take a look at the family tree of the CPU.
So the whole thing really kicked off back in 1971 with the invention of the first microprocessor. That was the first time an entire CPU could fit on a single chip. It was revolutionary. For decades after that, the game was just about making that single chip faster and faster. But around the mid-2000s, we kind of hit a wall. We couldn't just make them faster without them melting. So the industry shifted gears to multi-core processors. The idea was, hey, if we can't make one brain faster, let's just put multiple brains on the same chip. And that's the world we live in today, with companies like Intel and AMD leading the charge.
And here it is, the one that started it all, the Intel 4404. I mean, look at it. It's almost impossible to overstate how big of a deal this little guy was. This was the first time a whole CPU was on one commercially available chip. It's the invention that literally made the personal computer possible. Every smartphone, every laptop, it all traces its ancestry right back to this. Just an incredible piece of history.
Now it's interesting because not all CPUs are designed the same way. There are two main schools of thought. On one side, you have CISC, that's Complex Instruction Set Computer. Think of these as having a very rich vocabulary. They can perform a really complicated multi-step task with just a single instruction. On the other side, you have RISC, Reduced Instruction Set Computer. These use a much simpler set of instructions, but each one can be executed incredibly quickly. As a rule of thumb, the powerful processor in your desktop or laptop is probably CISC, while the super efficient chip in your phone is almost definitely a RISC design, like the ones from ARM.
And remember we were talking about multi-core a minute ago? Well, this is exactly what we mean. When you're shopping for a new phone or a laptop and you see things like dual-core, quad-core, or even octa-core, all that's telling you is how many of these little independent brains are packed onto that one single chip. And the benefit is pretty simple. More cores means the computer can juggle more tasks at the same time. It's the reason why multitasking on a quad-core phone feels so much snappier than on an old single-core one.
But wait, there's a twist. These days, the CPU isn't the only brain in the machine. There's another player on the field that's become absolutely essential, especially for certain tasks. I'm talking about the GPU.
So here you can see them side by side. On the left, we've got our good old CPU, the general-purpose workhorse. And on the right, you have its partner in crime, the GPU, which stands for Graphics Processing Unit. And you can probably tell just by looking at them, they are built for very different jobs. They think in completely different ways.
Here's the best way I can explain the difference. A CPU is like a brilliant world-class chef. It can tackle an incredibly complex, multi-step recipe all by itself and do it really, really fast. A GPU, on the other hand, is like having an army of 1,000 line cooks. You wouldn't ask them to create a gourmet meal, but if you need to chop 10,000 onions all at once, they can do that instantly. This parallel processing is what makes GPUs perfect for graphics in video games or making all the animations on your phone look silky smooth.
Which brings us to a really interesting question, right? We've seen the brain of the computer evolve from a single core to multiple cores, and now to a team of different specialized processors like CPUs and GPUs working together. It's not just one genius anymore, it's a committee of experts. So, as we keep pushing the limits, you have to wonder, what will the brain of tomorrow's computer even look like?